Okay, imagine this. You're on a plane, settling in. Maybe you just took off, or you're, moments from landing, everything feels smooth, totally routine. And then bam, out of nowhere, the plane lurches, the nose pitches up or down violently, and alarms just start going wild in the cockpit. For the pilots up front, it's probably not a broken part, it's wind shear. Sudden, often invisible, and really, really dangerous. So today, that's what we're diving deep into. Wind shear. It's this critical thing in aviation, often misunderstood. Our mission here is to really unpack it. What is it? Why is it so dangerous, especially down low, near the ground? And how are pilots trained to, well, first avoid it, and then, if they absolutely have to, recover from it? Think of this as your shortcut to getting smart on a complex topic. We're hoping for some real aha moments, maybe some surprising facts along the way.
Yeah, absolutely. And our guide for this is Captain Ashutosh Chopra's Commercial Pilot's Handbook. It's a fantastic resource, really practical, no-nonsense stuff. It's full of insight into what pilots actually face day to day. So we'll be leaning heavily on his expertise to, shed light on this.
Great. So let's start peeling back the layers then, this invisible threat. For anyone who's maybe heard the term but doesn't quite get the full picture, what is wind shear, basically?
Okay, so fundamentally, wind shear is any rapid change in wind. Speed, direction, or both, happening over a really short distance in a small area. It's not just like a gust of wind. It's a significant shift, and it can seriously mess with how the plane flies.
A significant shift.
Okay.
And where does this usually hide? Does it just pop up anywhere?
It kind of can, yeah. You often find it near thunderstorms. They're notorious for it, generating really severe shear. But it also happens around weather fronts, where different air masses meet. And within jet streams way up high. Also, when air flows over mountains, that creates mountain waves. Even in perfectly clear air turbulence or sea cavity. Oh, and severe temperature inversions, too, where you get that weird layering of cold air trapped below warm air. Basically, anywhere air masses clash or the flow gets seriously disturbed.
Right, so it's not always tied to a big, obvious storm cloud. Yeah, that's surprising. And how bad can it actually get? Is it just a bit of a bumpy ride, or are we talking something much more serious?
Oh, it's a whole spectrum. Mild wind shear?
Yeah.
Yeah, that might just cause some turbulence. Uncomfortable, makes it a bit harder for the pilots to keep the plane exactly where they want it. But high-intensity wind shear, that's a different game entirely. It can actually cause the plane to stall or trigger what pilots call a jet upset.
A jet upset. What's that exactly?
It's basically a major uncommanded change in the aircraft's attitude, pitch, roll, yaw, or a huge airspeed swing. The plane essentially gets thrown into a state that's very difficult or impossible to control. And if that happens, especially if it's mishandled, you could completely lose control. And down low near the ground, that could tragically mean hitting the terrain.
Wow. Okay, that paints a pretty stark picture.
And what's really sobering, Captain Chopra points this out very clearly in the handbook, recovery from some of the most severe wind shear conditions. It might actually be outside the capability of both the aircraft and the pilot.
Outside the capability, that's chilling.
It really is, isn't it?
Yeah.
That one line kind of shatters the whole myth of, pilots always being able to fix anything. It acknowledges that sometimes physics just wins, no matter how good the plane or the pilot is. So it's not just tricky weather, it's a fundamental limit. And that makes avoidance not just the best option, but really the only truly safe strategy. Because sometimes, there's just no coming back from it.
That reality must make avoidance almost like the number one rule in the cockpit, though.
Oh, absolutely. There's this great saying in aviation, maybe you've heard it. A superior pilot uses his superior judgment to avoid situations that would require his superior skills.
Right. Makes sense.
And wind shear avoidance is the perfect example of that. Seriously, the best way to handle wind shear is just don't fly into it, period.
So how do they do that? What tools do they actually use to spot it and stay clear, especially if it's often invisible?
Well, the main piece of tech is the weather radar. Pilots need to be absolute wizards with it, not just know how it works, but really interpret those complex displays. It's fundamental.
Right.
But beyond the tech, it's deep knowledge of meteorology, understanding why wind shear happens, where it's likely, how strong it might be. It's combining the radar picture with that foundational weather knowledge.
But what if the radar, breaks or misses something? Can they still sense it coming? That seems like needing a sixth sense almost.
That's a really important point. Look, you have predictive warnings from the radar and actual warnings from things like the EGPWS, the Enhanced Ground Proximity Warning System. They're critical.
Yeah.
But equipment can fail, so pilots absolutely have to be mentally geared up to spot the very first subtle signs, even without an alarm blaring. It's about constant, relentless vigilance.
Okay, so what does that avoidance strategy look like in practice, say before they even push back from the gate or while planning the flight?
It starts way before takeoff, with really digging into the weather forecast. If wind shear is predicted near the airport, they'll strongly consider delaying takeoff. Just wait it out.
Yeah.
And they won't fly if certain key equipment is broken, things on the minimum equipment list, the MEL. If the weather radar's out or the EGPWS isn't working right, that's often a no-go if wind shear is a possibility.
Makes sense.
They might also look at using a different runway or a different departure path, or the same for approach and landing, if the wind conditions favor it. And they're constantly listening, paying super close attention to reports from other pilots, PREPS, and messages from air traffic control, ATC. It's all about building that situational awareness, keeping their eyes and ears open.
Right. But even with all that planning, sometimes the unexpected happens, right? So if avoidance fails, if they do fly into it, how do pilots actually recognize it's happening? What are those immediate signs they're trained to look for?
Yeah, this is fascinating. A really sharp pilot, someone who's truly vigilant, can sometimes pick up on initial trends in the instruments. Tiny changes that hint wind shear is coming, maybe even before an actual warning. But the time you have to react preemptively is, well, it's often incredibly short. Seconds, maybe. So spotting those cues fast is vital. And they recognize it in two ways. Physically, the seat of the pants feeling, but mostly and critically through their instruments.
You said instrument indications are key. Can you give us an idea of how subtle these signs can be? What kind of small shifts trigger this massive response?
Right. Think about this, especially when you're below 1,000 feet, so close to the ground.
Yeah.
It might not be a huge jolt initially. We're talking an airspeed change of just 15 knots from what they're aiming for. Or the vertical speed, how fast they're climbing or descending, changing by 500 feet per minute from expected. That sounds like a lot, but in context, it's a significant deviation. A pitch changed the nose angle of only 5 degrees, or drifting just one dot off the glide slope, that electronic beam guiding them to the runway.
Tiny margins.
Exactly. Even seeing the thrust levers in an unusual position for a decent amount of time, trying to fight whatever the wind is doing.
Yeah.
To us, these might sound small, but to a pilot, those are like flashing red lights. It just shows how precisely everything is monitored. And there's a really useful tool on the airspeed indicator called the speed trend vector. It's like a little arrow showing where your speed's heading in the next few seconds. An unexpected movement on that vector. That's an immediate heads up. It's often much quicker than try to judge the overall speed change yourself. Pilots watch that thing like a hawk during critical phases.
And whose job is it mainly to spot these? Is it all down to the pilot actually flying?
No, absolutely not. Crew coordination is everything. That's why there are two pilots. The pilot monitoring the PM, the one not physically flying at that moment. They're often in the best spot to see these initial trends. Why? Because they're scanning all the instruments while the pilot flying the PF is focused on keeping the aircraft stable. The PM has to shout out any deviations immediately because, like we said, the window for acting preemptively, it can be incredibly tight. Seconds matter.
Okay, so they've spotted it. Or maybe an alarm goes off. They know it's wind shear. What happens next? What is the actual wind shear escape maneuver? Sounds intense.
It is intense.
Yeah.
And it's a precisely choreographed sequence. See, when a plane flies into wind shear, especially something like a microburst that's a really nasty downdraft, a whole cascade of things happens very, very quickly. We're talking maybe 30 seconds from start to, well, the worst effects. It happens so fast it can totally overwhelm a pilot. Their control inputs can get out of phase. They're reacting to something that's already changed.
Can you break down what the plane itself is going through? What forces are hitting it?
Sure. It's a mix. If you suddenly hit an increasing headwind, your airspeed jumps up, and nose tends to pitch up. Hit an increasing tailwind, though, and your airspeed drops, nose pitches down. That's bad near the ground. Then you've got updrafts, rising air. They increase the angle of attack, the AOA, which is the angle between the wing and the oncoming air, too high, and you get the stick shaker, that physical vibration in the control column, warning of a stall. Downdrafts do the opposite. Reduce AOA, cause a loss of lift, and can also trigger the stick shaker if the descent rate gets too high relative to airspeed. Plus, you can get hit from the side beam updrafts or downdrafts, causing sudden rolls or yaws. And all this is happening amidst turbulence, which makes everything harder and can mask what the airspeed is really doing.
That is a lot to handle in half a minute. What if it happens right on takeoff, before they're properly flying?
Yeah, that's why briefing for potential wind shear during the takeoff prep is so important. You might have a huge storm cloud, a sea, behind you. Even if it's not directly in your path, it can blast tailwinds across the runway that just trash your performance calculations. So if they see strong wind shear ahead, or get a predictive warning before they reach V1, that's the decision speed, go or stop. They must reject the takeoff, hit the brakes. But what if it's silent wind shear? Maybe a sudden tailwind component just slows down their acceleration. In that case, the procedure is usually max thrust, keep going. If they haven't reached rotation speed, VR, by about 2,000 feet from the end of the runway, they rotate anyway at the normal speed, pitching up towards 15 degrees nose up to get airborne. But, and this is critical, trying to reject the takeoff very close to V1 with a tailwind is incredibly risky. That tailwind means your actual speed over the ground is higher, so you used up more runway, leaving less space to stop. Very dangerous.
Understood. And what about if they're already airborne, after takeoff or maybe on final approach?
If they suspect wind shear on approach, the standard procedure is immediate. Discontinue the approach, go around, perform a missed approach, and whether it's suspected or confirmed, the escape maneuver itself has to be executed immediately. No hesitation, zero delay. Even thinking about it for a couple of seconds could be too long.
Okay, so walk us through it. Plane's bucking, alarms might be going off. What are the exact steps?
Right. Step 1, pilot flying takes manual control. Click off the autopilot. Step 2, hit the TOGA button, takeoff, go around. This tells the flight directors, the FDs, to display specific wind shear escape guidance. Step 3, aggressively push the thrust levers to full rated power and disconnect the auto throttle to make sure it stays at max power. No automatic reductions. Step 4, check wings level. Step 5, initially pitch up towards 15 degrees nose up attitude. Then follow the precise guidance shown by the flight directors. Step 6, retract any speed brakes if they happen to be out. And here's a really crucial, maybe counterintuitive part. Step 7, do not change any other configuration. Don't raise the flaps, don't retract the landing gear.
Really? You wouldn't want to clean up the aircraft?
You'd think so, right?
Mm-hmm.
But the performance benefit in that moment is tiny compared to the risk. Changing configuration takes time, takes hands off the controls. It's a huge distraction right when focus is paramount. So the pilot needs both hands on the controls, flying the attitude. The pilot monitoring, meanwhile, their job is to verify full thrust is set, call it out, make sure it stays there, and monitor everything else.
So those flight directors, the FDs, they're basically showing the pilot the way out. How smart is that guidance?
It's very sophisticated. Let's take a Boeing 737NG, for example.
Yeah.
The FDs aren't just saying climb. They're constantly calculating the optimal pitch attitude. Initially, if things aren't too bad, they might just guide the pilot to hold a certain speed. But if the wind shear really bites, say, a strong tailwind hits, and the rate of climb plummets when that climb rate drops below a certain threshold, maybe plus 600 feet per minute, which is dangerously low, the FDs will immediately command a much steeper pitch, like 15 degrees nose up. It's an aggressive, calculated command to maximize climb performance right now and get away from the ground. And if the plane gets close to stalling, if the stick shaker activates intermittently because of, say, strong updrafts increasing the AOA too much, the FDs will actually adjust the commanded pitch slightly lower, just enough to stop a continuous stall warning, while still maintaining maximum possible climbs. It's incredibly dynamic.
Wow. Okay, so with all that going on, the FD's giving commands, the plane reacting, what's the pilot's absolute number one focus?
Pitch attitude. Always pitch attitude. They have to fly the commanded pitch or the target pitch like their life depends on it, because it does. They cannot chase the airspeed. In severe wind shear, you might have to accept a temporary loss of airspeed to maintain that climb attitude and avoid hitting the ground. Pitch is primary. And that's where the pilot monitoring is so vital. They're the second pair of eyes, calling out altitude, how far they are from terrain, what the wind is doing now, feeding that situational awareness to the pilot flying. That teamwork is absolutely essential.
It sounds like this maneuver demands just incredible precision under insane pressure. How do pilots get that good? It can't just be instinct, right?
Oh, absolutely not instinct. You react instinctively, you might do the wrong thing entirely. This has to come from deep ingrained muscle memory. But here's the interesting part. It has to be muscle memory combined with understanding. You do the actions almost automatically, but you have to know why you're doing each step. It needs to be deliberate, not just robotic. It's this weird combination of near instant reaction time, but also very mindful, very precise execution, not flailing, but calibrated, disciplined control inputs. And how do they get there? Practice, practice, practice. Hours and hours in advanced flight simulators, facing these exact scenarios over and over under maximum stress. They're even encouraged to just sit and visualize it. Armchair flying, walking through every single step mentally until it's absolutely flawless, until they couldn't miss a step, even if they tried. They even practice messing it up in the sim, to see where the common mistakes happen and how to recover from those too. Every second counts. And that flawless execution comes from just relentless preparation.
So it's definitely not just a case of follow the green lines on the display, even with those smart flight directors.
Exactly. That's a huge danger. If you just blindly chase the FD command bars without feeling what the aircraft is doing, your inputs can lag behind reality. You can get out of phase, actually making things worse. Pilots are trained not to exceed the pitch limit indicator, that marker showing the absolute maximum safe pitch before a stall. They definitely don't want to stall the aircraft. Yes, the FD logic might allow for an intermittent stick shaker sometimes, but the pilot cannot push beyond that with rough or overly aggressive inputs. It's like dancing with the aircraft in a storm, not wrestling it into submission.
So, wrapping this up, what does all this mean for you listening in? Whether you're just fascinated by flying, or heck, maybe prepping for a high-stakes meeting yourself. Well, it means that every time you fly, there's this incredible depth of skill, knowledge, and just rigorous training happening up front that most of us never see. Pilots aren't just drivers. They're like master strategists, weather experts, split-second decision makers, constantly planning, anticipating, preparing for stuff like this. The kind of detail in Captain Chopra's handbook, that's not just academic theory. It really shows the sheer dedication to safety that defines aviation. What it takes to guide hundreds of people safely through threats you can't even see.
Yeah, and maybe the final thought to leave you with, connecting it back. It makes you wonder. Right. In those moments of extreme stress, could be a cockpit, could be anywhere in life, what really makes the difference between getting through safely and not? Is it just raw gut feeling? Or is it relying on that disciplined training, that meticulous prep, that deliberate practiced action? Aviation's answer, especially with something like wind shear, seems pretty clear on that.